Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera and a very good afternoon. Honorable guests, presenters, participants, ladies and gentlemen. I am Jessica from UniKL MIIT, your MC for today. Welcome to the opening ceremony of the first International Visualization, Informatics and Technology Conference IVIT 2022 through visualization, informatics, and computing technology. We are connected via Microsoft Teams and Facebook Live at UniKL page. It is my pleasure to welcome everyone this afternoon, and I would like to thank you all for joining us today. We wish to remind everyone that your microphone will be muted during the ceremony, and for better viewing, kindly set your setting to full screen mode. We shall start the ceremony shortly. Please stay tuned with us. Thank you.
Demi satu keunggulan bangsa yang berdaulat, sebuah lambang menawan puncak jaya, perkasa di persada dunia. Obor para cendekia merentas masa hadapan, usahawan jaya pencipta bahagia, maju mara maju jaya, mara berkasa menjunjung amanah rakyat, memayungi bangsa dan negara, semangat berintis, penuh yakin, demi satu amanah mulia, marah berkasa menjunjung amanah rakyat, memayungi bangsa dan negara, penuh keyakinan demi satu kejayaan marah, nahoda kemajuan siswa-siswi mahir inovatif berdikari. Universiti Kuala Lumpur, insan ilmu dan teknikal kita, nahoda kemajuan teknologi di lautan, di daratan, dan di langit tinggi. Universiti Kuala Lumpur, pelopor teknologi tertinggi, nahoda kemajuan negara kita, lumpur di mata dunia. Universiti Kuala Lumpur, pusat ilmuwan teknikal kita, nahoda kemajuan teknologi di lautan, di daratan, dan di langit tinggi. Universiti Kuala Lumpur, pelopor teknologi tertinggi, nahoda kemajuan negara kita, lumpur di mata dunia. Nahoda kemajuan negara kita, lumpur di mata dunia. Universiti Kuala
Malaysian Institute of Information Technology, yang berbahagia Associate Professor Insinyur Dr. Muhammad Khairil Rahmat, Director, Center for Research and Innovation, University Kuala Lumpur. Distinguished guests, academia, presenters, participants, ladies and gentlemen. A very warm welcome to the opening ceremony of the first International Visualization, Informatics and Technology Conference, IVIT 2022, embarking IR 4.0 journey through visualization, informatics and computing technology. On behalf of the organizing committee, we would like to thank all esteemed guests and participants for being here with us today. This conference is organized by University Kuala Lumpur, Malaysian Institute of Information Technology, UniKL MIIT, and technical co-sponsored by IEEE SMC Malaysia chapter. Allow me to quickly brief you on the flow of our two-day conference, which will be taking place via the digital platform. The conference starts today with 5 presentations this morning and will continue with another 2 sessions after the keynote speech. Tomorrow morning, the conference will start with 2 keynote speeches, followed by another 5 presentation sessions. The closing ceremony is expected to start at 4:30 p.m. tomorrow. Ladies and gentlemen, before we proceed with the agenda, let us begin with the recitation of dua that will be led by Dr. Abdul Aziz Hadi. Please welcome.
السلام عليكم ورحمة الله وبركاته. أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. يا أيها الذين آمنوا أطيعوا الله ورسوله ولا تولوا عنه وأنتم تسمعون ولا تكونوا كالذين قالوا سمعنا وهم لا يسمعون إن شر الدواب عند الله الصم البكم الذين لا يعقلون ولو علم الله فيهم خيرا لأسمعهم ولو أسمعهم لتولوا وهم معرضون يا أيها الذين آمنوا استجيبوا لله وللرسول إذا دعاكم لما يحييكم واعلموا أن الله يحول بين المرء وقلبه وأنه إليه تحشرون واتقوا فتنة لا تصيبن الذين ظلموا منكم خاصة واعلموا أن الله شديد العقاب. الحمد لله رب العالمين. اللهم لك الحمد حمدا كثيرا طيبا مباركا فيه. اللهم لك الحمد بالإسلام ولك الحمد بالقرآن ولك الحمد بالأهل والمال والمعافاة. اللهم لك الحمد حتى ترضى ولك الحمد إذا رضيت ولك الحمد بعد الرضا. اللهم صل وسلم وبارك على نبينا محمد وعلى آله وصحبه أجمعين. اللهم إنا نسألك العفو والعافية والمعافاة الدائمة في الدين والدنيا والآخرة. اللهم إنا نسألك رضاك والجنة ونعوذ بك من سخطك ومن النار. اللهم أصلح لنا ديننا الذي هو عصمة أمرنا وأصلح لنا دنيانا التي فيها معاشنا وأصلح لنا آخرتنا التي إليها معادنا واجعل الحياة زيادة لنا في كل خير والموت راحة لنا من كل شر. اللهم وفقنا لما تحبه وترضاه وجنبنا ما لا تحبه ولا ترضاه يا رب العالمين. اللهم وفق القائمين على مؤتمر ال IVIT 2022 لما تحبه وترضاه وأعنهم يا رب العالمين لإنجاز هذا المؤتمر على أكمل وجه يا رب العالمين. ربنا ظلمنا أنفسنا وإن لم تغفر لنا وترحمنا لنكونن من الخاسرين. ربنا هب لنا من أزواجنا وذرياتنا قرة أعين واجعلنا للمتقين إماما. ربنا آتنا في الدنيا حسنة وفي الآخرة حسنة وقنا عذاب النار. سبحان ربك رب العزة عما يصفون وسلام على المرسلين والحمد لله رب العالمين. الفاتحة.
Amin, amin, ya Rabbal Alamin. Thank you, Dr. Abdul Aziz, for the dua recitation. Honorable guests, presenters, participants, ladies and gentlemen, we have now come to the highlight of the ceremony, the opening remarks by our guest of honor. With that, it gives us a great honor to cordially invite Yang Berbahagia Associate Professor Dr. Dahlan Abdul Ghani, Head of Research and Innovation, University Kuala Lumpur, Malaysian Institute of Information Technology, to deliver his welcoming remarks. Please welcome.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi ta'ala wabarakatuh. And a very good afternoon. Associate Professor Dr. Khairil Rahmat, Acting Deputy President, Academic Technology, and also Director of Research and Innovation, Unicel. Management members, Unicel MIT academic staff, IVIT committee members, distinguished conference presenters and participants. Assalamualaikum and very good afternoon. Alhamdulillah, my deepest gratitude goes to Allah Subhanahu wa Ta'ala because it is grace and permission we are able to participate at the first University Kuala Lumpur Unicel MIT Malaysian Institute of Information Technology Conference, known as the International Visualization Informatics and Technology Conference IVIT2022, held through virtual from the 1st to 2nd November 2022. This conference is organized by the University of Kuala Lumpur Unicel MIT and supported by the IEEE Systems Man Cybernetics Society SMC Malaysian chapter. This conference provides a platform for intellectuals from various fields and disciplines in the area of visualization, informatics, information technology, computer technology, and also to provide a platform to debate and discuss the current issues worldwide, as well as finding solutions to the problem, exchange and sharing their knowledge within each another. Unicel MIT, playing as a host of the IVIT 2022, showcases Malaysia's capability as the competitive digital nation, and at the same time, this effort ensures that Malaysia is not left behind in terms of technology and innovation ecosystem. Dear researchers and participants of IVIT 2022, IVIT 2022 indeed has able to attract many researchers, scholars and participants from around the world, including India, Indonesia, and also not to forget from our local IPTs in the country, including from UiTM, Al-Bukhari University, Utah, Taylor's College University, University of Malaysia Kelantan, and many more. Hence, all these listed papers presented in IVIT 2022 will be included in this corpus proceeding IEEE Explore. IVIT is the first conference organized by Unicel MIT and also successfully has able to attract almost 130 papers submitted, and also indicate that this conference has accepted well and able to create a proper network among the peers and scholars to exchange ideas and knowledge in the respective field in line with the IVIT 2022 conference theme, embarking IR 4.0 journey through visualization, informatics and computing technology. IVIT 2022 also has attracted several industries and individual sponsors to ensure that the conference effort to stimulate the technology and innovation system, and also to provide a proper ecosystem in line with the national agenda under the Keluarga Malaysia. Dear researchers and participants of IVIT 2022, we hope that IVIT 2022 conference will be able to promote digital literacy and an effort that will increase awareness on the importance of technology adoption and innovation among Malaysians in line with the current developments that are happening around the world. Malaysia's ability in utilizing new and innovative technology to ensure that the country's recovery amid the pandemic was evident. In my sincerest wish that IVIT 22 will be utilized in the best way possible to aid discussion, inspire and spark new ideas in the development of technology and innovation to elevate the country's international level. Also not to forget, my extreme gratitude goes to all Unicel MIT academicians, IVIT participants, and also not to forget the industry and sponsors, including from partners as ASK Pentest, Bintulu Port, and also experts Sdn Bhd, and also IEEE management and committee members for supporting and leading momentous event. With these wishes, I would like to end my speech with Wabillahi Taufiq wa Hidayah. Wassalamualaikum warahmatullahi wabarakatuh. Happy conferencing. Thank you.
Thank you for the warm welcome, Yang Berbahagia Associate Professor Dr. Dahlan Abdul Ghani. Honorable guests, presenters, participants, ladies and gentlemen. Now, it gives us a great pleasure to invite Yang Berbahagia Associate Professor Insinyur Dr. Muhammad Khairil Rahmat, Director, Center for Research and Innovation, University Kuala Lumpur, to deliver his speech and officiate the first International Visualization, Informatics and Technology Conference IVIT 2022, embarking IR 4.0 journey through visualization, informatics and computing technology. Please welcome.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh, and warmest greetings from UNI KL. Alhamdulillah, let us extend our sincere gratitude to Allah Subhanahu wa taala for giving us the opportunity to be here today for the International Visualization, Informatics and Technology Conference, IVIT 2022. I would like to welcome all of you, and especially the overseas speakers and participants. Selamat datang. And welcome to the first ever virtual conference organized by UNI KL MIIT. I want to thank the committee for their efforts in making this conference a success. I've been told that the conference has managed to get many entries from local universities as well as overseas participants and researchers from Thailand, India, Indonesia, and the Philippines. Additionally, the committee was able to get sponsorships for the events from numerous business associates and secure eminent speakers from Malaysia, Austria, and Australia to provide a keynote address. The theme chosen for this IVIT 2022 conference is embarking IR 4.0 journey through visualization, informatics, and computing technology. It is actually an ambitious and realistic goal for the IT and computer sciences area, where we are moving towards data analytics, visualization, and different technology in the computing domain. Inshallah, I strongly believe that this conference, seminars, and intellectual discussion within the IVIT 2022 are important and are able to assist the Center of Research and Innovation and UNI KL, together with all the IPTA and IPTF within, in planning and executing effective future programs for each campuses of UNI KL and others in general. I hope the outputs obtained from these various studies and papers through various papers have been presented during this 2 days conference will shed some lights on the issues and challenges, as well as opportunity related to advancement in area of research and data sciences. Before I conclude, once again, Alhamdulillah, we like to congratulate the organizing committee for organizing this conference. This effort, I must say, is a very commendable and should be continued in the future, inshallah. To the participant, thank you very much for the support for this conference and for UNI KL. And thanks for committing your time and energy towards this conference. I wish all of you the best of luck and to have a very fruitful discussion within. With the lafaz of Bismillahirrahmanirrahim, I hereby declare the International Visualization, Informatics and Technology Conference IVIT 2022 to be officially open. Inshallah. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi taala wabarakatuh. Thank you very much.
Thank you, Yang Berbahagia Associate Professor Insinyur Dr. Muhammad Khairi Rahmat. Honorable guests, presenters, participants, ladies and gentlemen, let us sit back and enjoy a special montage presentation to commemorate the opening of IVIT 2022.
Turn up,
With that, it is my pleasure to introduce our keynote speaker for today, Professor Dr. Adam Jatowt from Department of Computer Science, University of Innsbruck. Professor Dr. Adam Jatowt is an academic researcher from University of Innsbruck. The author, he has contributed to research in topics, web page and automatic summarization. He has an H index of 27, co-authored 228 publications, receiving 2,794 citations. Previous affiliation of Professor Dr. Adam include National Institute of Information and Communication Technology and Kyoto University. Honorable guest presenters, participants, ladies and gentlemen, without further delay, I would like to cordially invite Professor Dr. Adam Jatowt to deliver his speech titled Towards Automatic Question Answering and Generation from Large Temporal Document Collection. Please welcome.
Hello, can you hear me? Hello? Am I audible?
Yes, yes. Sorry.
Okay. Yes, good. Thank you. Thank you very much for inviting me to give a speech here at this conference. I'm very much honored. And yes, maybe I will already start. So you can see the title is about question answering and about large document collections. But in particular, this will be about temporal document collections, so-called big archival data, as we call. Archives such as you have newspaper archives, book collections, even web archives where you can check old pages of your institution, your company, how it looked like in the past and so on. And we have many other archives like social media, product review collections and so on. So we call this kind of data archival data because it of course collected over time, and these collections are continuously growing. And in that kind of collections, publication dates are very important because they define when document was created, when it was published. So in this context, there is actually a growing field of computer science, which is called cultural heritage informatics. As you can see, this is a definition of cultural heritage informatics, like interdisciplinary research, which is basically related to creation, capture, organization, and pluralization of culture as heritage. In this context, there is also a subfield of this, which is called archival informatics. That is a theory and application of informatics in processing in the realm of archives and record keeping. And that is where our research somehow sits in or is related to. Of course, it's related to question answering as well, but we are working on archives, on document archives. And just to give you examples of the size of this kind of data, which we call big archival data, you see these are the numbers. For example, a project of chronicling America collected already 5 million newspaper pages from, I think it's about at least 100 years of American history. Then we have a Times digital archive with 3.5 million articles over about 200 years. Google Books, this initiative claims to have scanned about 5% of books ever published. So this is a really huge number. And then we have an Internet archive, which contains a lot of page snapshots from the past over more than 15 petabytes of data collected from 96 until now. And then every national library and archive basically have their own digital collections. This of course comes with big costs. So for example, Japanese National Library spend a lot of money just for digitization of their content. And we think that this is wonderful data, cultural heritage data, but despite this data is available, it's open to users and also huge costs, which went into preparing such data, still the number of users is small. So in our laboratory, we are trying to popularize document archives, basically make them very accessible and easy for everyone, for average users, not only for professionals, using computer technologies. And you can see here it's a list of challenges when we process such kind of temporal data. So first of all, the data can be large, but also can be fragmentary. In certain years, you might have a lot of news articles. In others, you may have missing articles. So there's uneven distribution over time. The quality of data, if we look at the data for the last decades, several decades, it should be fine. But if we go farther in the past, we have OCR errors, different document style, different layout. Vocabulary is also changing. So you have semantic evolution of some words. You have different words used in different senses over time. And then another challenge is that there is a lack of any NLP methods or lexical tools designed for this kind of data, especially if you look at particular time period in the past. We also don't have a WordNet. We don't have part of speech taggers for any period in the past for any language. And finally, the context is changing. So any user accessing such data may not understand what was the context in particular time period in the past, who was a president at the time, what was the situation, political situation, social situation, and so on. So our knowledge of the past is limited. So as you can see, these are quite interesting and novel, I would say, challenges of this kind of data for computer science. However, this is a really large amount of data about our heritage, about our past, and we feel like there is a need to provide good access tools to this kind of data. So let's see at the what is the interface, information access interface to document archives. So if you have a large document archive, obviously the data is arranged over time. Most of the documents have timestamps. And let's suppose a user has certain query that wants to send to the archive. For example, what music devices were used in the past? Perhaps this is a student writing the master thesis on this topic and wants to analyze things like Discman, Walkman, or some even older devices to listen to music. And search results will come. Usually they are just returned like a standard search engine by keyword relevance. But then looking at these results, they come from different time points. They are from different sources, and user maybe lacks a context to properly understand because he or she is not an expert. Well, it will basically be difficult to make sense of such results. They are just arranged by relevance, but they are taken from different time points from the past. So we think we need more user-friendly solutions, basically some AI component between archive and a user that will take users' information needs and basically satisfy them. So what kind of solutions this AI could be? Well, we could try to order search results perhaps by time or by relevance and time together combined, which is not easy to decide which one should be there and how to do it. We can perhaps try to somehow structure the results, summarize them, cluster perhaps, so it's easier for the user to check what is returned from the archive. Or we could perhaps provide some more information to these results, some explanation taken from Wikipedia, links to news articles that perhaps follow up certain stories. There are many possibilities here, but we took another way. We think that why not to try to directly answer what user is asking for about the past. So basically this will bring us to question answering. And we would like to build a system that takes a natural language question from a user against such an archival large temporal collection and answers it. Just in a short answer, like we observe now already in a Google search engine, that when you send a query, you also have a list of questions related to your query with ready answers already extracted from web pages. And this kind of application could be useful not only for historians, not only for students writing a thesis, but also for journalists, for lawyers, or even employers in insurance, finance that want to assess a risk, check something from the past, and forecast or be able to forecast future easier. So here you can see example of questions from our data set that we try to satisfy, that we try to answer, and they are actually issued against 2 million large news article collection from these 2 decades, from 80s and 90s. Oh, sorry, also the last decade, 2010s. So you see these questions. What bill was signed by Clinton for firearms purchase? Which US professional pitcher died because his small airplane crashed in New York? These are rather detailed questions. Here are the answers. Here are also the event dates. And that is what we want to produce. Basically take such a question and provide a ready answer from the collection. So a little bit about question answering field. It's actually not a new research. It has been going for, I would say, a couple of decades at least. And typically questions here are issued against Wikipedia or some short-term collection of news articles or perhaps scientific publications, because we also have Q&A over scholarly data. But basically there is little work on temporal document collection. So most of them are on asynchronic document collections, as I said, like Wikipedia, but there is little bit done on the temporal collection, where of course publication dates of articles are very important. Context changes over time, the sense of words can change over time. You have many other challenges, as we already have seen. So here will be an agenda for the remaining part of my talk. I will first talk about our unsupervised Q&A approach to such collections, then improvement of this approach by better estimating event time, and finally about our initiative to build a large-scale open domain Q&A dataset for such collections. So let's start with the first unsupervised approach, and this was our first method that we tried. when we wanted to basically solve this task. But we realized there is no collection to train the system, so we couldn't take any supervised approach. So here is a very, very brief overview of the system that we built. We call it KANA, Question Answering in Use Archives. And basically it was working over New York Times collection. So it was taking a question from the user, like this one, and looking for all these news articles and trying to find an answer and providing basically a brief answer to the user question. What we focused on actually is this part, retrieval unit. So in a standard question answering research, you have two components, retrieval and reader. Retriever takes from the collection of documents and given a user question, takes some relevant documents, some candidate documents, while reader unit will actually check them and pick up the answer. Of course, there could be some more stage like post-processing of answers or merging, aggregating several answers. But basically, typical systems are built based on these two components, retrieval and reader. And in our research, we focus on the retrieval unit. So basically, this is information retrieval approach to this task, to our question answering task on archives, which means that given millions of documents, we have to select a small subset of such documents, relevant documents, that will be likely containing the answer to the user, and then we'll basically use some standard reader methods to pick up these answers. So let's look more at the example of questions, because there are two categories of questions that could be issued by the user. We call one of them explicitly time scoped. So these are the questions that have a date, like you can see at the end here mentioned. So this basically indicates from where more or less a user wishes to extract the answer. But also we have another category, implicitly time-scoped questions, where you don't have any temporal information. So basically you don't know where to look for over the time in the news collection. And we especially focus on this category because this is more challenging and also probably more likely to be issued, these kind of questions, by average users that may not know the correct dates of events. So our approach first takes a question and then basically extract keywords from this question. We use a Yake keyword extraction system. And then we use a initially standard retrieval operation, which is based on BM25, basically looking at the keyword overlap, keyword match, and we retrieve top-end candidate documents. So a question is here. We make a query from the question. So basically we extract keywords from this question and then send it to the archive, which is already indexed, and return top-end results by these BM25 methods. This top-end could be 1,000 documents, could be 10,000 documents, of course, from a million of archived documents. But based on them, we also build a time series. So we position all these documents here over the time, and then we'll reason over this time series to better pick up more likely documents out of this top-end. So let's see one time series of a document. So here is a question. Lewinsky told whom about her relationship with the President Clinton? And the dotted line here, the black dotted line, indicates basically the distribution of documents over time from 1987 to 2007. And we also applied peak prediction by using this cutoff here. And we found that the peak by displaying a moving average here would be somewhere here. And the I'm sorry, there was some disconnection. I hope you can see me. Okay, so I was talking about this time series plot, which was created from relevant pages for this question. And here we indicate the peak by red color, drawing a moving average line, and the actual event happened here. So maybe this is kind of simple question because we only have one peak over time and we know where to look for the answer. It should be somewhere here. But if you have another question like which Hollywood star became governor of California, then you see there are actually more peaks. Our system detected just 2 here, but the event happened in one of them, right? So basically, if we want to estimate a question time scope, so what time period the question relates to, this is not just one peak, one period, basically, but it could be a set of time periods. And here you can see more examples. Which TV network retracted unsubstantiated report about nerve gas usage? 2 peaks. Here, which English football team had 9 players arrested in Spain for alleged sexual assault? We see there are quite many peaks, and that is quite difficult from where we should actually select relevant documents for answering this question. So we propose 2 very simple rules or intuitions that guide a selection of relevant documents. First idea is that if we have 2 documents with their publication dates, and we already estimated this question time scope, as you remember, it was the period corresponding to the peak on the time series, then we can say that document DA, which is closer to this time scope, should be more relevant to answer a question than document DB, because it's naturally just closer to the question time. So that's one score, we call it publication time score. Each document we have such a score. And then another intuition is that a document like this DB, which contains a date in a text, of course, that fall within the estimated question time scope should be more relevant than another document that perhaps have no temporal expressions, or those temporal expressions do not fall within this estimated time period, which we call a question time scope. So here is a content time score. Basically, we combine these 2 scores for documents and then can re-rank documents, these top and return initial documents, re-rank them so we have more likely ones on the top that contain the answer to our question. Of course, this is a very simple intuition, what I showed to you here, but mathematics behind it is a bit more complex. We use kernel density estimation, and we have not just one period as a question time scope, but if you remember, for some questions you have a set of time periods. So this is a bit more complex to aggregate such information, but nevertheless we can do it in unsupervised fashion. So then we can basically combine these 2 scores, as I said, and re-rank documents by combination of these combined temporal scores. But also we consider relevance score, because initially this documents return has also some relevance, like by BN25, as we have seen. So we can see which one is more having more keywords overlapping a question. So we combine relevance and time score, but the combination here is actually not just a simple linear combination, but we look at the time series and we say, okay, in this kind of cases where you have just one peak, you actually should be looking more at temporal score of the documents when you re-rank them. But in this case, where it's less certain where we should look at, time perhaps does not give you much information. You rather look into more relevance and less into temporal scores of documents. So then, as I said, by analyzing time series, we can re-rank these initial n results and then pick up a smaller number k of them. So let's say 100 or 50 out of perhaps a couple of thousands or a couple of hundreds. And then from here, we apply document reader approach and answer a question. For example, the answer, and we provide the answer. For example, this could be the average or most common answer, which is in these documents like this. So a little bit about the evaluation. We use a New York Times annotated corpus from 87 to 2007. That's about less than 2 million articles. And then we didn't have any collection of questions and their answers. So we had to manually prepare 500 questions. Half of them were sorry, 500 explicitly, 500 implicitly timescopes, so in total 1,000 questions. And they were taken from some quiz websites, from Wikipedia pages, from other existing Q&A data sets, if of course time period of a question fell within our corpus time period. And we also published this data set. So let's see at the results. So here we have two metrics, F1 score, the other is exact match. So whether returned answer is exactly matching what is the ground truth gold answer. And our system Kana is here. It has the best metrics over considering different number of top re-ranked documents. And here we have some baselines plus also two variants of our system without temporal publication score and temporal content score, which, as you see, altogether provide the best solution, these two scoring fashions. And we also compared our system with Wikipedia. So can we answer this kind of detailed question about past just using Wikipedia? And here you have a system using Wikipedia and system using New York Times and also our system. And then for top one, indeed, there is slightly better results, but farther on, if we use other numbers of top results, just Wikipedia does not contain all the information that we need. So it has to be collected from archival data, which is more detailed, which is basically eyewitness accounts of the past events. And then we also analyzed if our dynamic combination of relevance and the time score and relevance score, it makes sense. This is the alpha, and we found that as here using the dotted line, this gives the best results for exact match and F1 score for different n numbers. So it was a good solution rather than just picking one only static value of alpha. So I will move on now to the second part of my talk, which is further improvement of this research. And we published a paper on SIGIR 2021 on this. And basically the idea here was that the question time scope that previously you have seen was detected by simple burst detection on the time series is actually not a good way to do so, because we might have minor events that have no burst, or we can have periodical events, we have multiple and noisy bursts. So we need a better way to detect this question time scope. So basically, to what area of time or time period a question relates to, where we should be looking for documents to answer this question. And here we formulated the task in a more general fashion, not just a question, but any description of an event we take as an input. And we take also some granularity of time, let's say monthly or daily or yearly, and our news collection. And the task is to provide occurrence date of this event, event E, using granularity and document D as a data source. So let's see an example. If we have a description of an event like this, a bombing of a super ferry by Abu Sayyaf in the Philippines killed 116 people, we want to basically say, perhaps with a monthly granularity and using our archive, we want to say when this happened. And the answer is 2004-02. So we wanted to build a system which takes this kind of three elements and provides an answer here. Can you still see my slides? Is everything okay? Okay, it seems perhaps it's fine, but if there is any problem, please write on the chat on yes, okay. Right, so you can see the model is here. Now we take just any event description. It doesn't have to be a question, but basically it's just the content, text content, granularity, and then we estimate using time series, using the archive, estimate the date. And this date will be, of course, used for a question answering system, because it's much better precise date estimation that we actually did previously. And let's see more examples. You can see this is from our data set, a couple of events, and the task is to provide the time when this event happened using underlying news archive collection, just like here. And for example, the last two are not mentioned at all in Wikipedia. These are perhaps too small events to be mentioned in Wikipedia. Or this one does not have daily or monthly granularity information. It's just a year only that is mentioned for this event. So how we solve this task? So we basically took our event description. Of course, there is also decided granularity. We took the news collection and generated 4 time series from this news collection, which is publication date time series, where are relevant documents located to this event description. We took a content date time series, so what time expressions are in the relevant documents for this event description. And then 2 more time series, which is documents to event relevance, so basically similarity score, and sentence to event similarity score. So we tried to generate many time series that will, over this time period of the archive, tell us where it's likely that the event happened. And altogether, this goes into transformer module, which is using 2 convolutional layers, and then block of transformer encoder, and further softmax and embedding averaging in order to provide event occurrence time. So I will not go into the details because there is much more behind, of course, this approach, but due to limited time, I will now show the results, and then we can talk about the last part of the keynote. So we use again the New York Times annotated corpus, but this time we had much larger collection to train also and also test our approach, because we collected from Wikipedia descriptions of events. So Wikipedia has a year pages, and for every year they list most important events in this year. So you can basically grab many sentences, each one corresponds to some event, and precise date when the event happened. Basically 22,000 such event descriptions distributed over time like this. And then here we tested many approaches, and the last line is for our approach using transformers. The pre-last line is using CNN. And here you can see daily, weekly, monthly, and yearly granularity with accuracy and mean average error. What we can observe is that many baselines have quite low values here, because if you take RG, which is a random guess, randomly pick up a day over 20 years long time period, then of course this will be very, very low accuracy. But you can see that our approach was not, of course, perfect and not very good, but much better than random guess in terms of accuracy to picking up a particular day of event occurrence. And this is also this good performance compared to many baselines is also repeated for weekly, monthly, and yearly granularity. If we look at the time series, the 4 time series that we use, and we do analysis, if we remove other time series and just pick these 4, or perhaps combination of the 2 or total of them, we see that actually all of these time series contribute to having a good result. So it makes sense to provide much information, temporal information to the system. And here I show you 3 examples of difficult events for which our system could not provide a good answer. The first one, actually, it's about Halloween party, so it's a timely, let's say, event. But our system had about 6 years wrong judgment. Well, mainly because this event was just not mentioned in New York Times. It was mentioned in Wikipedia, but somehow not reported in New York Times. Another problematic event was this flu outbreak in Britain puts pressure on NHS. Well, that is periodical event because it probably happens every year or a couple of times in a decade at least. So it's very difficult to judge, probably impossible for humans even, when this happened. Or here, Turin, Italy, is awarded 2006 Winter Olympics. Our system said this is 2006, but actually it was 99 because that's about awarding Winter Olympics, not about Winter Olympics taking place. And obviously there was a lot of misleading dates for the system in that case. And here finally you can see our question answering system equipped with this more precise query time scope detection, and you can see that we managed to improve further the results by using a better precise way, more precise way to estimate when the event happens, events that underlie user question. So this is the last part of my talk. And here we try to build a large-scale Q&A data set for such temporal news collections because we came to conclusion that unsupervised approaches will not be performing very well. Question answering is now predominantly based on supervised approaches. So we look into Q&A data sets that are now available, and you can see several of them listed here with the size of them. Some of them has over a million, but actually this is just a closed test-based question answering, which means hiding one word in a text and trying to uncover this word. But many of data sets are in the range from 100,000 to 200,000 questions. And they are, most of the time, they are either on Wikipedia, on some common sense questions, medical, a bit on the news, and so on. But basically, there was no question answering data set over long-term temporal collections of news articles, like, let's say, 2 decades or more. So we wanted to build it, but to build 100,000 or 200,000 large data set of questions, you would really need a lot of money to ask crowdsourcing teams to basically provide such questions manually. So we thought, like, why not to create automatically such a data set? And here we use question generation, which is another recently very much developing area of research. Basically, the text is taken and a question is generated from this text, like this one. So basically, we use question generation methods to generate a data set, to make a data set which will help later question answering research. And of course, we didn't use all the questions which we generated because many of them were not good or too simple or too long and so on. So we use many aggressive filtering steps to refine from about, I think initially we had about 3 million questions that we generated up to 500,000, but good quality questions. And I will talk mainly about these filtering steps, which are basically here indicated by these 3 stages. So we take our collection of documents. We actually pick up some events from Wikipedia, so the questions will be related to some important events, not just something randomly pick up from New York Times. But then, as I said, after generating these questions, we have many of these filtering here steps, basically 4 filtering steps, and I will talk mainly about them. After just briefly discussing how what method we use to generate questions. So we basically used, let me come back to the previous slide. We used a T5 model, which is large pre-trained language model that was fine-tuned on popular Q&A question answering data set like Squad, which is not especially for time or archival collection, but still we could fine-tune such a model to generate questions from our data. And basically we considered every entity in input paragraph as the answer, and then highlighting it as an answer, we could generate a question that will use this answer. So basically, in the end, we would have such a question answer pairs, provided also with information about paragraphs where the answers were can be found and where the question was generated from. And I mentioned these filtering steps, so I will maybe skip this middle filtering step, which is about syntactic filtering, so like too long sentences, too long questions, or questions that have some unresolved pronouns, like who was he, for example, or I don't know, what was his name? We don't know who is this person at all in such a question. So obviously we remove them. But more interesting are these filters about content specificity and temporal ambiguity. So let me explain them. We basically wanted to have rather specific sentences like the second one here, than more general sentences like the upper one, because making question from the first one, well, such question would probably not be answerable because we don't know what is it about. But here we have, you have many name entities. This is more precise information, and then I think this kind of content can give rise to the question that is basically meaningful and is answerable. So to remove such general sentences, general paragraphs, and retain only specific ones, we basically train our classifier using Roberta base, and we had a data set of general specific sentences already prepared by other researchers. So we could train our classifier there, achieving about 85, a bit less percent accuracy, and then we could remove anything that was judged as general and retain only specific paragraphs. Then from those specific paragraphs, we generated questions. And one more filtering step is temporal ambiguity related filtering step, because some questions, due to their periodical character, or maybe due to the lack of information, are basically not answerable. If you have a question like, who was the senator of West Virginia? We don't know when, so there is no one answer. Of course, the system may pick up one answer because that's what it was in the paragraph from where the question was generated, but well, average user or any Q&A system will not know what to return here, or how many points does this person have, or what did Syrians want to add. These are not good questions. They are too ambiguous over time, and we wanted to rather retain this kind of questions, like how old was Evelyn Sabin when she died, or who sent 2,000 American troops to Bosnia. And here you have answers. So we built again classifier with BERT, and we annotated ourselves about 5,000 questions, whether they are such temporally non-ambiguous like the first two, or temporally ambiguous like the last four, to remove this kind of ambiguous questions. And finally, we had more than 500,000 question answer pairs retained. They are distributed over time like this. And you can see some example sample questions, like who claimed responsibility for bombing of Bab Azur. Here is the answer. Some more information, the paragraph ID from where the question was made, and the source. So basically, was it prompted this question by a Wikipedia year, or just it was randomly selected from New York Times? And so this kind of questions we generated. And we further divided also the data set into easy and hard by basically looking how many results are returned by using standard search engines. So the hard part would mean there are basically quite few relevant results returned, and for easy there are many relevant results. We also divided data set into those questions that have time or no time, and prepared such a subsets here that anyone can train their systems on especially such a part of data set. And then we tested several approaches using also dense retrieval, not just bag of words retrieval. And we observed that exact match, for example, if we compare on the hard subset of questions versus easy, they are lower on the hard than for easy. And surprisingly, when the question has time, like this Q&A times portion, it has lower results than for the case when there is no time, because most of the systems here that we tested, they do not consider time in any special way. So this information might be even misleading. So I will now conclude my talk. So these were three basically topics that I introduced for this new research task of question answering on temporal document collections. And first I proposed unsupervised approach. Then I discussed how to improve this unsupervised approach by better estimating the time scope of questions. And then later, finally, I show how to build a large-scale question answer data set in a automatic fashion, by first generating questions and then aggressively filtering these questions to retain a smaller subset of high quality questions. And you can actually use the same approach for another Q&A task, perhaps not temporal questions, but maybe on publications or questions on some medical documents. And you can utilize the same approach in a more automatic fashion to have a really large data set. Perhaps manually made questions will be of better quality, but then you could have perhaps two data sets, an automatic one and manual one, and use the first one for pre-training your system, and then for fine-tuning you can use a better quality manually made Q&A collection. And just to show a little bit about my team, what we have been doing in this subfield of computer science, which we call archival informatics, we have also worked on causal relation detection in archives, on analogy estimation from news archives, comparative timeline summarization, and also on topics like finding interesting, surprising content, or content that is relevant to current users, so contemporary relevant content. And this is one of the latest research in archival informatics that we do. That is, of course, automatic question answering that I today introduced. As for the next steps, what we want to do, so we will work on multi-hop questions. And multi-hop questions are the ones that you need to visit several documents to merge information from those to provide the answer. So the answer is not just stated in one document, but you need to do several hops, let's say combine, merge information, or logically compare in order to infer the answer. And we already wrote a survey on multi-hop question answering. So we are now building solutions to this. Then we could have also future work of comparative question answering. You may ask something about one event as well as another event, and then the answer needs to somehow compare information from two events. The answer, so we can formulate the answer. And then we also think that if we don't provide some context to the user, just only giving the final answer, maybe that's not too good, because user may wish to have some more understanding why the answer is as is. And so we think about some comprehension-oriented solutions, perhaps using Wikipedia to provide more context. This will be further research. Basically, it all goes into one direction for our group, which is how to effectively return data from the past for the current users, how to make it in a user-friendly way. So with this, I will thank you for attention, and I'm happy to answer any questions, and also happy to collaborate if anyone is interested in these topics.
Thank you for the speech, Professor Dr. Adam Jatowt. Now we open the floor for Q&A session. If you would like to ask any question to Professor Dr. Adam Jatowt, you may unmute your microphone, or you can write your question in the chat box, and I will read the question on your behalf. All right, we have one question from a viewer in FB Live. Okay. How does the system answer questions that have words that contain different meaning? Example, present and present.
Yes, so it's a case probably of a multi-sense, let's say, words or ambiguous question that may have several meanings. Well, we assume that the questions in this initial work, at least, we assume the questions are well formed. So the user is rather precisely formulating a question. Obviously, this is an assumption here, limiting assumption. But just like with humans, if a question has several meanings, then even a human will not properly answer it. So here we just make this assumption that perhaps a most dominant sense of a word is taken if the word has several senses. I hope that answers the user's question, the question from the audience. Thank you.
Thank you, Prof. Any other questions? Prof, can you please disable your screen sharing?
Just a second. Yeah.
Okay, thank you.
Sorry, Miss Jessica, there's a question in the chat. You can check the chat.
Okay.
Okay, so the question is it possible to apply web scraping on the archives as part of the algorithm? So we already had a collection ready, right? So all these news articles were just in our local machine. We didn't have to do any web scraping. But if someone wants to include more news articles, of course, you can do some web scraping and collect from some online sources, news articles, and include them. You can also even do it on Web Archive, perhaps, where you can see the past versions of web pages, and you also do web scraping there. But that is preparing a data set. We rather focus on, once you have a data set, how to retrieve effectively information from the past for this data set. But you can, of course, include more steps to grow this data set, continuously perhaps grow, so you don't have only 2 decades from the past, but you have all the history, let's say, from 1980s until now, and add more and more articles there. You can use perhaps some API, maybe no need to do web scraping. Maybe some news sources provide in an easy way data without the need for web scraping. Thank you for the question.
Okay, thank you, Prof. Any more questions from the floor? Okay, so I think we can proceed to the next section. Okay, honorable guests, presenters, participants, ladies and gentlemen, the keynote speeches now. We have come to the end of the opening ceremony of IVIT 2022. On behalf of the organizing committee, we would like to thank our esteemed guests and everyone for your presence during the opening ceremony this afternoon. Before we end the ceremony, we would like to invite our honorable guest, Yang Berbahagia Associate Professor Dr. Dahlan Abdul Ghani, and all our esteemed guests to switch on your camera for a group photo. Can we have everyone ready? Okay, on the count of 3, 2, 1, smile. Okay, one more shot, everyone. Okay, on the count of 3, 2, 1, smile. Okay, one more. Okay, last one. On the count of 3, 2, 1. All right. Thank you everyone for the photo opportunity. Okay. Distinguished guests, ladies and gentlemen, kindly be reminded that our parallel sessions tomorrow would start at 11 a.m. and everything can be accessed via Microsoft Teams as per link stated in the event schedule. Till we meet again, we hope that everyone would have a fruitful time participating in this conference. Thank you.
Thank you, Prof.
Uni KL, kita datang.